This is a video for Calculus AB 2009, 2009 Form B, number 6. We've got a table here with some times and some velocities in meters per second, and the times are in seconds here. So just kind of scanning through over 40 seconds. I've got moving forward faster, and then somehow it got to be moving in the negative direction, and then negative direction a little slower, negative direction a little slower, and then a positive direction again. All right. Velocity, it's a differentiable function, so we can talk about slopes of this, like any kind of average, like mean value theorem. That means that's in play. Where the position x is in meters, time is in meters per second. Selected values of velocity. Particle is at position x equals 7 when time equals 0. That reminds me, or makes me think of fundamental theorem, because we've got an initial value there. Okay. Let's see what they want us to do. So for part A, estimate the acceleration at time 36. 36 is right in between these, so a good estimate would be to find the slope here. Acceleration is the slope of this, so acceleration at time 36 is approximately the velocity at 40 minus the velocity at 32 over 40 minus 32, which is 11 over 8, and that would be 11. I'm subtracting velocities here. That's meters per second per second. You can write that as meters per second squared if you want to. That is totally fine. For part B, using the correct units, explain the meaning of this. Well, if we take the integral of velocity, that gives us displacement, right? So let's do it this way. So from 20 to 40, that would be the position at 40 minus the position at 20. Which is the displacement. And using the correct units in meters. All right. Use a trapezoidal sum with the 3 subintervals in our table here to do 20. So we're going from 20 to 40. So I've got 1, 2, 3. And trapezoidal sum. Got to know how to do trapezoids. I'm still in part B here. So to do trapezoids, you do the width of the trapezoid divided by 2 times the sum of the 2 heights. That's trapezoid number 1. That's 5 wide. Divide by 2 always, and then add these up. This one is 7 wide, and put that over 2, and then add those up. Plus 8 wide. You want to show, don't simplify this as you go. You want to show what you're doing here so somebody can come along and look at this and say, oh yeah, that's a trapezoidal sum, all right. Okay, so now we will simplify. This is negative 18 divided by 2 is negative 9 times 5 is negative 45. Negative 12 divided by 2 is negative 6 times 7 is negative 42. 8 divided by 2 is 4 times 3 is 12. So that's negative 85, I think? No, negative 75, sorry. And we're finding the area under velocity, so that'd be, and we're doing that displacement, that'd be meters. And that's good for part B. Part C, For time 0 to 40, must the particle change direction in any of the subintervals indicated by the data in the table? If so, identify the subintervals and explain your reasoning. If not, explain why not. Well, positive velocity moving forward, negative velocity moving backwards. So does it have to change direction? Yes, because if it's differentiable, then it's also continuous. So v is differentiable, therefore also continuous. So what's the theorem that says that if a continuous function goes from 5 to negative 10, that it's got to cross over 0? That is the intermediate value theorem. We're not talking about slopes here, we're just talking about the actual values of this. So by intermediate value theorem, the IVT, V of t must equal 0 on the interval from, let's see, from 8 to 20. Oops. You could do those open or closed, it doesn't matter, like regular parentheses or closed. They don't mind whichever. Somewhere in 820. And also we got a sign change here on the interval from 32 to 40. Right? It's got to happen. All right, that's good for that. Oh, sorry, could you see what I was writing there? There it is. So since v is differentiable, it's also continuous. That means the intermediate value theorem applies, and all that. All right, remember when you use the intermediate value theorem or mean value theorem, you have to invoke them by saying that the function's got to be continuous for the IVT. For the mean value theorem, it has to be differentiable, which is stronger than continuous. Okay, last part. Suppose that the acceleration of the particle is positive for times 0 to 8, which could be, right? Because it's going from 3 to 5. So they're saying it's positive the whole time. Explain why the position of the particle at time 8 must be greater than 30 meters. Okay, if the acceleration is positive, so v of 0 is equal to 3, and v of 8 is equal to 5. I'm going to make a little sketch for myself. So here's time 3. Here's time 0. Here's time 8, going from 3 to 5. All right, so if the acceleration is positive, that means this is positive slope, so this doesn't like dip below 3. So that would mean that on that time, on the times from 0 to 8, v of t, the velocity is at least, we say, greater than or equal to 3, right? Because it's got to go up to 5. So if it was 3, then 3 times 8 seconds, so the displacement from t equals 0 to 8, if it's going at least 3 meters per second for 8 seconds, that displacement has to be greater than or equal to 24 meters. Right? That would be that area right there. It cannot be less than that. I mean, it's got to be really, if it's getting all the way up to 5, but that would be like an absolute minimum. If it somehow like barely crept up and then whoosh, shot up to 5, it could be like just barely bigger than 24. It would be weird, but it could be. So I guess it's got to be greater than 24. Anyway, that's fine. And we know that the position x sub 0 is 7 meters. So the position at time 8 must be greater than or equal to 24 meters, the displacement, plus 7 meters. So it's got to be at least 31. So that's some fancy footwork there. That little, I feel like that graph helped us understand a lot what was going on there. All right, that's definitely in the category of like kind of weird questions where you're like, what is this question about? What's going on here? But you always have to understand there's nothing happening here that you don't know. You just have to kind of piece together what you do know and try to reason your way through it. All right.